Okay, so in this video, we'll talk about how to derive the ionic equations when you're given chemical equations. Okay, so in the previous video, we talked about this example. Okay, we actually broke down this equation into the ionic equation. So let's just move over to another example. Okay, let's just practice another example today. Okay, so these are very simple examples. Let's say. Okay, yeah. So we have these equations. Uh, let's just practice. Let's just practice over this equation, this particular equation, the third one. Okay, so Aslan, I need you to answer. Okay, Aslan and Arisha, I need you to answer. So, Aslan, what is going on here? What type of reaction is occurring? This is a similar type of reaction that we saw before.
Chemical reaction.
Yeah, of course, it is a chemical reaction, but what kind? This is a displacement reaction. Okay, once again, the more reactive compound, sorry, the more, not the compound, the more reactive element, that is zinc, is just displacing the less reactive element from its compound. So zinc is more reactive than iron, right? And that's why it wants to steal away the sulfate from iron. Okay, so it will just, just push away iron, right? And it will bind to sulfate and form zinc sulfate, and iron will be left all alone, right? So this is basically a displacement reaction. Now, if I want to form an ionic equation, what will I do? So the first step to form an ionic equation is to split up these compounds into ions. Okay, so I need you all to follow me. So here, I need your undivided attention. So I need to split up this chemical reaction into individual ions. Okay, so we have iron sulfate. So that gives us, I'll just zoom in, okay? So we have iron sulfate reacting with zinc, right? We need to make sure that we also take care of the state symbols, right? The states of these ions. So iron sulfate exists in the aqueous state, and that's why it is ionized, right? So iron, and we have iron, and since it has no, since there is only one sulfate polyatomic ion, so we know that iron has the oxidation state of 2 plus, right? Because sulfate is 2 minus, and they both cancel out. So iron 2 plus, and we have aqueous ions of iron 2 plus, right? Aqueous ions, and then sulfate, right? Sulfate 2 negative, and these are also aqueous. So we need to write the state symbols. And then we have zinc, which is solid. Okay, so that is not ionized because zinc is not ionized. And then I'll just take it over here. Okay, the niche requirement. So let's move on to the product side. I'll just write it in purple. So we have zinc sulfate, and that is in the aqueous form. So we know that we have to ionize, break it down into ions. So we have the zinc, and that's 2 plus, zinc 2 plus in the aqueous form, right? I'll just write Q for aqueous. And then we have sulfate again, so SO4, and it's 2 minus, right? And that's aqueous 2, right? Always write the state symbols, okay? And we have iron as a solid, okay? So we won't be ionizing iron. Okay. So now that we have broken down the chemical equation into the ionic equation, sorry, we have broken down the chemical equation into the ionic form. Now let's just, cancel out the ions which are not actually taking part in the reaction. So Rafi, can you tell me, sorry, Aslan, can you tell me which ions are not actually taking part in the reaction? Or Arisha, can you tell me which ions are not actually taking part in the reaction? So this is the reactant side, okay? And this is the product side, right? मैं नीचे लिखा है इसको. So as you can see here, that iron goes from aqueous to solid. So it does take part in the reaction. So it is undergoing a change. Sulfate goes from aqueous and it stays aqueous, right? Both on the reactant side and on the product side. And its oxidation state भी change नहीं हो रही. So you'll just cancel these ions out, okay? They're not actually changing during the reaction. Zinc, on the other hand, goes from solid to aqueous, so you won't be canceling this out. And that leaves us, and that shows that sulfate is not actually taking part in the reaction. And that's why we call them as spectator ions. Okay? Once you get knocked out of a game, once you get eliminated from a game, So you become a spectator, right? So these are known as spectator ions, and they're not actually taking part in the reaction. So if we just write down the resultant equation and the final equation, so it is like, uh, so we just write out the ions which are left. So we have iron, okay, Fe2 plus, right? And that's aqueous, obviously. Plus we have zinc solid, okay, and then we have iron, and iron was solid, right? So iron as solid, and then we have zinc as aqueous, okay, and obviously zinc is charged because it's aqueous. So, Azlan, what is the oxidation state of zinc on the reactant side? Zinc is in its free form, it's solid. Quick, what is the oxidation state of zinc?
Zero.
Yeah, it's zero. Okay, excellent. What is the oxidation state of iron on the reactant side? Arisha, what is the
Two.
ox 2? Okay, exactly 2. Or zinc की थी 0, right? So now let's move on to the product side. In the product side, अब क्या हो रहा है product side? So on the product side, अच्छा, you know what? We'll end the video here and we'll just discuss this in the next segment.